Most crypto investors and influencers don't actually fully understand the various blockchains that they're investing in. You'll see people compare different coins in long Twitter threads, but a lot of the time, the influencers don't actually know what they're talking about more than just reading what the blockchain says on their own website. They don't actually go in and verify that the things they say are true, and they kind of just take everything at face value. I'm guilty of this too. For the past year, I've been investing in a few coins, and I haven't taken the proper time needed to do a deep dive and figure out how it actually works. So join me today as I dive into what I have said to be my favorite blockchain, Tezos, and I'm going to figure out everything about it. Its history, the different technical design decisions that went into making it, and the pros and cons that present themselves from these decisions. After I do that, I'll figure out how to actually develop on the blockchain, and I'll try and create my own smart contract. If you're new here, my name is Max, and I studied computer engineering at the University of Illinois, and now I work full-time as a junior developer in Chicago, and in my free time, I try to make videos like these. I pretty much just Googled Tezos resources, then also from Tezos' website, they also have just these basic documentations, and then here I found this developer documentation. So yeah, hopefully I can kind of go through and kind of develop an actual framework for other people to go in and learn once I go through. But I'm going to start just reading through all of this and then come back with kind of like my recap. Just got done reading through the white paper. Shorter than I would have expected. It's like 17 pages. And not that dense, but I still don't really fully understand the proof of stake stuff. But I just kind of wanted to go through my overview, like what I've learned so far. Self-amendment means there's no hard forks like what Ethereum did back in, I think, 2017 with the DAO. On-chain governance, which is how the self-amendments work. So that's how you vote for proposals to amend the blockchain. Formal verification, kind of inherent with how the programming language that they used pretty much just validates the program so you can know what to expect. In practice, I'm not sure how much this actually helps, since the code can still be validated and functionally correct, but not do what you actually want it to do. You can have a logic error still, so still a good benefit though. Proof of stake, it's more efficient. You don't have the issue Ethereum has right now. And delegation, instead of having to set up your own staking, you can delegate to delegators who will pretty much do the staking and the actual facilitation of the blockchain themselves, which means that even if you only have a small amount of Tezos, you can still stake, and it's very easy to change your delegators. So it's kind of like voting in a political party. If you don't like how they're voting for different proposals, you can change your delegation easily. As for the actual white paper, blockchain's got 3 parts: the network, transaction, and the consensus. Tezos kind of abstracts the transaction and consensus part into just calling it the blockchain protocol. For the network shell, pretty much job is communicating the best the best chain to the client. And it also has to prevent denial of service or distributed denial of service DDoS attacks, but it doesn't say how, so kind of was a question mark for me. You also assume that timestamps can be faked. Makes sense. Also, to prevent some of the denial of service stuff, you limit some access on the block and transaction size. But again, it doesn't actually go into the details of it. It uses OCaml, which I've heard of before. It's pretty niche, but I think well-received functional programming language. It's kind of just functional, just means it's a paradigm of how you think about stuff, but I'm not going to go into that here. One thing I thought was kind of cool was it mostly stores the difference between transactions on the blockchain, kind of like software versioning, like Git, and a block hash. In my mind, I kind of equate that as a Git commit hash. So it's just one specific difference in the chain. The main way the amendment works is 2 functions: the set test protocol and then promote test protocol. And these can be used in a variety of ways. 5.4% nominal inflation, not sure if that's the same, but it's designed to just be neutral. Also, the Tezos Foundation, for the first 12 months, had veto power over amendments, which is interesting, but obviously that ended a while ago, so not an issue. The quorum amount changes based on how many people are actually participating in the network. 80% supermajority to promote it to the mainnet. Proof of stake stuff, I realized I really don't understand proof of stake as much as I thought I did. Smart contracts, basically a stateful account, which is a contract, and you have a manager assigned to it. And the manager is the one who's authorized to spend money from that smart contract account. Storage limited to 16,384 bytes. An origination is just initiating smart contract onto the chain. A transaction is kind of just the vague term for pretty much anything that happens on the blockchain. So it's going to be normal transfers between accounts, and at a high level, it's just a message sent from one contract to another contract. storage fee is one Tezos provide. Code is stack-based, and there's a hard cap on the executable code length, unlike Ethereum, but that can be amended, and there's ways to like split it up already to like work around it. So that's my takeaways now. I'm gonna take a lunch break and then go back to learning more. Now I want to take some time to do a deep dive of how the governance and amendment process actually works. So sum it up, there's 5 stages. Each one takes 2 weeks, which is how we end up getting the whole like from start to finish process takes about 2 months. But at any point, if we fail one of the periods, fail one of the stages, we go back to the first one, which is the proposal period. So at this point, the bakers can propose amendments, and in order to go on to the next one, we need to reach a 5% quorum, and whichever one just has the most upvotes is the one that goes into the next period, which is the exploration period. Otherwise, it goes back to the proposal. In the exploration, we need to hit a quorum, which is, like I said, the number changes depending on how many people are actually participating, but it's about 70-80% usually. And it also needs an 80% supermajority. So assuming 80% of people vote yes, it goes on again to the testing period, though this isn't actually called the testing period anymore. They call it the cooldown period. Testing happens throughout this whole process now instead, and no voting happens here. So then we go on to the promotion period, which I guess is kind of like the final vote. Here again, we need to reach a quorum, and we need to hit a 80% supermajority. Assuming it passes from this point, you hit a 2-week adoption period, which gives everyone time to upgrade and use the latest amendment version, and then you go back to the proposal again. So to go into some actual examples, Tezos Agora is the website kind of just used for governance and tracking everything. Each of these numbers is a period, and you can see corresponds to either cooldown, exploration, and proposal. You see most of them are proposals. If we go here, this was the last one that got actually approved, hangs out. So you can see here we had proposal. It was proposed. This is the one that had the highest upvotes. This is one that got selected. You go to 57. I guess click up here. This was the exploration phase. So you can see 93% in favor, so passed supermajority and it reached quorum. Was the cooldown testing period. Nothing happened. And then it was the promotion phase. And here again, the quorum was 53%. Looks like we had 67% participation. Supermajority was 80%. We had 99.39% in favor. Then looking at 60, we had the adoption phase. We had proposal, nothing got proposed. 62 proposal. We had Ithaca. This one was a little bit controversial, and it actually, as you can see, went into the exploration phase and failed here at 71% participation, but 77% were in favor, so it didn't reach the 80% mark. So we went back to proposal. This time Ithaca 2, slightly modified version, won 16%. You can see the controversial part was actually this liquidity baking stuff. So this one was highly upvoted, but not enough. So 65, we just had the exploration phase, 100% in favor. Quorum was met 53%, but somewhat narrowly, as you can see. 66, we're in the cooldown period of 2 days left, and then we'll go back into the promotion phase, and hopefully, like Hang Zhao, it'll be met and it'll go and be adopted. So something to note that I'd recommend you dig in a little bit more, can actually figure out about, is that there was a lawsuit against Tezos and the Tezos Foundation back in 2017 that was cleared up in 2020. I listened to some interviews with Arthur and some other videos, and I've come to the conclusion that it was just kind of angry investors and people using the fact that ICOs were like a gray legal area on whether or not it's a security to try and just make some money off of it. So for me, I don't think this is an issue, but if I'm making a whole video on diving deep into Tezos, it'd feel pretty shady for me to not bring it up. So yeah, I'm gonna start actually working with the code side of things and developing. So thanks to Twitter, found this great resource that I didn't actually know about before today from B9 Lab, and let's just go. So I've already got Docker set up. Let's just get the testnet set up. Nice. So we can see now I've got Hang Zhao net. and it's doing everything. Sweet. I've been going at this for like an hour now, maybe an hour and a half, and I'm kind of stuck. It's like sort of working, but I think I did something to break Docker. I think at this point, I'm just gonna move on to smart contracts. Taking a look here, we have a repeater one, which pretty much just takes a storage and repeats whatever you pass into it. It's just normal Python code. We import SmartPy, normal class, repeater, normal init. So right now we're passing in the string as kind of like the challenge that it had for me. The entry point is this repeat function. And this test just tests calling .repeat. And we can see the type is .string. So actually, like, this is the actual compiled Michelson code. Pretty much like the actual stack code. It's pretty much the same thing as like assembly, if you're familiar with that, which is like, you can figure it out, but it's not fun to develop in, which is why C and C++ and that stuff exists. So that's why SmartPy exists, to make it a lot easier to add tests for, and you know, ends up compiling down to the same thing anyways, but with like comments, which helps. And so if I do the first example again without the string and change the storage to be, say, 0, you'll see that instead of being a string, it's type int or nat. Pretty cool. So pretty much SmartPy has their own versions of like the Python standard library functions. For example, instead of just doing like for I in range, you'll do like sp.for I in sp.range. The best way I can explain this, or how it makes sense in my head, is doing this lets SmartPy optimize the compiled Michelson contract in a way that's most efficient in doing the least operations. They've also got like sp.if and while. So yeah, that was just a quick update. All right, also I just found the actual SmartPy reference docs. There's a lot more than I thought, but I guess I would have expected this. And this actually looks pretty complete as far as documentation goes. Another thing I didn't mention, I got these like you can fail with for like checking like validations if you have a param or not. There's also just sp.verify or validate. Yeah, here, sp.verify for checking params and making sure, you know, they exist or they're within a certain range. We have some actual progress. So I followed the guide for like certification. Pretty much you just have a certifier address, which is like the address of like the administrator, I guess, or like the certifier, whatever. So in this case, it's like my faucet address. And then you have a list of, it's a big map. So from address to name, it's like to just keep track of a list of like people who have been certified, whatever. Just a simple example that I followed along. There were a few issues towards the end. Mostly it just doesn't really tell you how to deploy. It shows you some screenshots of it, but like not what to do. So I had to figure it out, but it's not too bad. Certification, it's contract. We init, we have the certified, which is a big map, mapping addresses as the keys, strings as a value, with the certifier, which is this address, just my test faucet account address. Then you have the entry point, certify params. You verify that the sender is from the certifier, and then we add the map from that address to the name. So to do it, I just over here did deploy Michelson contract, clicked on this, pulls it up, changed it to hangs out net, testnet, SmartPy, faucet. First I imported this, but afterwards you can just click here, boom, select it. Just can estimate the cost to get the right cost. You just hit deploy and it deploys. Super easy. And so here you can see, like this is how it looks just when you do it. Waits till you have all 10 block confirmations, or you don't have to wait, it doesn't really matter. And then you can open up the Explorer. We can see, like this is the node. There's been one operation, 128, yeah. Here it was. So you can see I called certify with this address, and the name was test account. You can see here we got test account. And so like to test it, let me paste in here. my address, and the name, let's say test2. Build the parameters. Let's do it from my faucet account. Send the transaction. Accept it. And status is applied. So you can see my args was string address, then the name was test2. But you can see we have two operations. These was our parameters. Now my question is, I don't know if there's a way to just like get like a snapshot of what the storage looks like, you know, to see like I have test account and test2. Aha. So you can see, call it certified twice. Oh, I'm so dumb. No, it's because I keep overwriting the address. So I just keep updating. Like, like this address, the key is the same every time. So I just keep overwriting that. So that's why I can only see one. If there was more, you'd be able to see more. So perfect. It's working as expected. I followed through this next one, copied all this code. It's just a test. And yeah, the challenge is trying to implement it myself. So, all right, I actually did it on my own. It kind of works, I think. So let's check it out. We got class crowdfunding. It's a SmartPy contract. We init with the self, owner, minimum amount, deadline. Initialize that with owner's owner, minimum amount, deadline, and then the funders, which is a big map with addresses to mutez, microtez. Then we have an entry point, which is send fund with no parameters. We verify that funders does, so this little squiggly is not, or it's SmartPy's version of not that like compiles efficiently. So we make sure that they haven't already donated, so you know they're not contained in that big map. And we verify that now is less than the deadline. And then we set that hash with their address to the amount that they sent, since sp.amount just gives you the balance in the transaction. Then another one is payoff. So this is the current balance in the contract. We check that that's more than the minimum amount. And then we check that it's past the deadline, assuming these are true. Then we send to the owner the current balance with the message successful crowdfund. Then we have refund. Again, we check that the time is after the deadline, that the funders contains the sender. So we have to make sure that they actually contributed already. Again, assuming that they are, we send to the requester the amount that they funded with the message crowdfund refund. And then we delete that from the big hash. That way that they cannot request it twice. Here's our contract. The first one works, we do 10. Second one works, we do another 8. You can see we've got the two users in the map. Third one doesn't work because we try and do it again with user 1. They already donated. The payoff fails because we haven't hit the minimum. Here, this works. User 3 sends in 15. Yeah, we're not before the deadline, so it fails again. We transferred 33 to the owner. I guess the difference is they used a map instead of a big map. I'm pretty sure when you're dealing with addresses, you have to use a big map. So I've been told, but maybe you don't have to. There's a reason they did map. Don't know. Docs aren't perfect. Who knows? Send fund. They verify that it doesn't contain it, exact same as me. And that so they call it max time instead of deadline, and they just did the inverse of mine. So I did now less than, they did max time greater than or equal to. So same thing. The payoff, good to know. I guess this is like an implementation detail. Here they also check that the owner is actually the sender. I don't do that, but I'm sending the data only to the owner. So I guess anyone could start the payoff, but it would still just go to the owner anyways. So whether or not that's a flaw, up for debate. Refund, they check that it contains it. Yep. The time. It would have been good. I guess check that the minimum amount is, or I guess in this case it would be that the way I'm doing it would be that the balance is less than or equal to the minimum amount. Yeah, so that one would be important. I missed that one. And then they do sp.send and delete, exact same as me. Not bad for my first smart contract. We did it. first smart contract. Let's try and deploy this, I guess. So I just modified the owner to be my test faucet address. I'm pretty sure there's like a better like way that you're supposed to deploy these contracts and like pass them in and originate it. Possibly from the command line might be the right way to do it. But this works and it doesn't matter. So got this, I decided to do 5 Tez, and the time I'm only doing plus 180, which is 3 minutes. I already hit run. This doesn't matter because that's just my tests later. I just care about this part. See, owner is correct, minimum amount 5, perfect. So deploy. Now we only have 3 minutes to work with this. So, all right, I think I know my issue. This should really be, timestamp should be 180,000. Put this up. Send fund from this guy. 3 Tez. Applied. There we go. Now if we refresh, balance is 3. If we try to pay off, it will fail. Nice. I think something I'd like to learn next is getting much better reject reasons. I'm sure it's just a matter of like passing through like a message with the verify, but later issue. And then if we send fund from the one that we already donated from, it should also fail because we already donated. Nice. So that's it. Obviously it's only on the test net. You know, if we wanted to be real, we could do it on the main net too, but pretty happy with this. So my day learning Tezos, diving deep into it, is done. It's 9:56, just about 10 o'clock. I think I started this video, it was like 11:30, 12. So all in all, spent probably like 7-8 hours on it. Nice way to spend my day off. Obviously took some breaks, you know, lunch, dinner, took a little walk. So yeah, I guess just to recap, started off, just dug into kind of just the documentation that is online about Tezos at a high level. Read the white paper, figured out all the design decisions that went into making Tezos. Went through the self-amendment governance process, some examples of recent proposals that have failed, why they failed. Talked a little bit about the controversies, you know, the lawsuits that happened. And then finally dug into the fun part, you know, actually developing on it, even though I ran into a hiccup actually running my own node. That's not really the important part for what I'm trying to do, what I'm interested in. I'm more interested in actually developing it. And using SmartPy for the smart contracts was pretty easy. So I think my next video might be actually making something cool, you know, my own idea. I don't know what it'll be yet. I'll have to brainstorm. But yeah, thank you guys for watching. I hope you guys learned more about Tezos and kind of, you know, how you can do your own research if you are trying to invest or just learn more about cryptos. Because there's a lot of, I don't want to say like purposeful misinformation out there, but a lot of people just kind of talk like they know what they're doing, or, you know, they have money invested in things and they don't actually do their due diligence to figure out where their money is and, you know, the people behind it, like what's actually happening behind the scenes for it. So yeah, thank you everyone for watching, and I see you guys next time.